this question that we have this block which is attached to the spring of spring constant K. Both the blocks are of mass m and this block is coming with velocity v. Striking this block, they undergo a perfectly inelastic collision and the two blocks stick together. We need to find out the amplitude of resultant SHM. Now for solving this question, the first thing that should come to your mind is that you have to use the concept of energy here. In a SHM, an SHM has a very important property that the total energy of an SHM is always conserved. So we use this property over here. First of all, let us find out what happens after collision. This block of mass m coming with velocity v strikes with this block of mass m already at rest. Finally, both of them stick together to become a single block of mass 2m and they remain attached to the spring. Now for the very small duration of collision, the spring force being a conservative force, its effect during the small interval of collision can be neglected. Therefore, we can apply momentum conservation on the system of these two blocks for the small time duration of collision. So we get mv is equal to 2m v dash. Therefore, we get v dash is equal to v by 2. V dash is equal to v by 2. So we know the velocity of the combined block system after collision. This is mass 2m going with velocity v by 2 towards right. Initially the spring is not compressed. Therefore, this becomes the equilibrium position of the motion of the block, and this block also executes SHM, as we already know that the spring block mass system always executes SHM. So this is the equilibrium position of the SHM of the block. Now we know that at the equilibrium position the total energy of the SHM is in the form of its kinetic energy and the potential energy stored in the spring is 0. Therefore, the total energy of the SHM which is conserved is equal to half 2m into v square by 4, and we know that the total energy of an SHM is equal to Ka square by 2. Always remember this, the total energy of an SHM is equal to Ka square by 2. So we equate this to Ka square by 2. So we get amplitude is equal to m upon 2k root over into v. So our final answer for the amplitude of the resultant SHM comes out to be root over m by 2k into v. An important concept which we learned in this question is that the total energy of an SHM is always conserved, and you will be required to use this property many times in further questions, in more difficult questions. And the hint which we get in this question which prompted us to use this total energy concept was that there was something related to velocities happening over here, and we were asked about amplitude, and amplitude of an SHM is always related to the total energy of the SHM, and amplitude of the SHM is not dependent on the frequency of the SHM, it is only dependent on the total energy of the SHM.